Hey everyone, welcome back to the Deep Dive. Today we're going deep, really deep, into the world of linked lists.
Linked lists, yeah.
We're going to find out why they're like the unsung heroes of the digital world.
That's right. They're everywhere.
You're going to be shocked, maybe even a little amazed at all the places these things pop up.
Seriously, from your music apps to, well, your computer's operating system.
Exactly. And we're going to break it all down, make it
Yeah.
super clear how they actually work.
Should be fun.
All right, so first things first, for anyone who needs a little refresher,
Sure.
what exactly is a linked list? I mean, I know it's a data structure, but
Yeah, so picture it like a chain, right?
okay, a chain. I like it.
Each link in that chain, we call that a node.
Gotcha. A node.
And each node is holding on to like a piece of data.
All right, so like what kind of data?
Could be anything. A song in your playlist, a website you visited, even like details about a process your computer's running.
Okay, so that's the data part, but what makes it a list?
Ah, that's where the link comes in. Each node also has a little pointer, basically an arrow that says, hey, the next piece of data is over here.
So it's like a treasure hunt, each node leading to the next.
You got it. And that simple structure, that chain of nodes, that's what makes linked lists so powerful.
Okay, I'm starting to see it, but let's get concrete.
Sure.
You mentioned playlists, right? How does a linked list make shuffling actually work?
Think about it. If your playlist was just a big block of data, like an array,
Hmm.
shuffling would mean moving all that data around every single time.
Ugh, that sounds like a nightmare.
Total nightmare. But with a linked list, you don't have to move anything.
Wait, really?
Yep. All you do is change those little pointers.
So like instead of physically rearranging the songs?
You just tell each node, hey, point to this song next, even if it's out of order.
That's brilliant. So much faster.
Way faster, way more efficient. That's the beauty of linked lists.
Okay, that's making a lot more sense now.
Uh-huh.
So where else do these linked list superstars show up?
Well, let's talk about your browser history.
Ooh, good one. I use that all the time.
We all do. So every time you visit a website, that becomes a node in a linked list.
Okay, so my entire browsing session is like one big chain.
Exactly. And the back button?
Yeah.
That's just moving you back one node in the list.
So simple, yet so powerful.
And fast not, because it's just following those pointers, no searching through tons of data.
I never realized how much work was going on behind the scenes.
It's happening all the time.
Now, I know linked lists can get even more complex. How about we talk operating systems?
Ooh, getting into the guts of your computer now.
Right. I hear they play a role in how computers multitask.
Absolutely. Think of your OS like an air traffic controller, juggling all these different processes.
So many programs running at once, it's mind-boggling.
And each process is a node in a linked list.
Okay, so the OS zips through this list, giving each process a little bit of time.
Exactly. That's how your computer seems to do a million things at once. It's rapidly switching between them, following those pointers in the linked list.
So it's not really doing everything simultaneously. It's just really good at switching.
Yep. Lightning fast, thanks to linked lists.
This is blowing my mind. We've covered music, web browsing, now multitasking. What other magic can these linked lists do?
Let's talk undo do.
Oh, yes. The lifesaver of every computer user.
Right. And behind that undo button, there's often a special type of linked list.
Special how?
It's called a doubly linked list.
Doubly.
Yep. Each node has two pointers.
Whoa, why two?
One points to the next node, like usual, but the other points backwards to the previous node.
So it's like a two-way street.
You got it. So when you hit undo, the program just hops back to the previous node.
It reverses time.
In a way, yeah. And redo, that just hops forward again.
So every action I take, it's like creating a new node in this list, and I can move back and forth.
Exactly. Think about like a text editor. Every keystroke, every delete, every formatting change, that's all a node in the list.
And the under arrow just lets me travel through time, changing my mind as I go.
It's a safety net for all those oops moments.
Can't imagine life without it. So doubly linked list for the win.
Definitely a game changer.
All right, I think we're ready for some more advanced stuff.
Bring it on.
Earlier, we touched on caching and how it makes websites load faster.
Right. Remember those frequently accessed pieces of data?
Like images, code, that kind of stuff.
Exactly. And linked lists can be used to manage that cache really effectively.
Really?
How so? Well, there's this algorithm called LRU, least recently used.
LRU.
And it basically says, hey, the stuff that hasn't been used in a while, that's probably safe to get rid of.
To make room for newer stuff.
Right. And a linked list makes it super easy to keep track of what was used when...
Because it's already ordered, each node pointing to the next.
Precisely. The least recently used stuff ends up at the tail of the list, so it's the first to go when the cache gets full.
That's so smart.
Yeah.
But are there ever times when a linked list isn't the best choice for caching?
Oh, for sure. Like, if you need to find a specific piece of data really quickly,
Uh-huh.
a linked list can be slow because you have to go through the chain one by one.
You just jump to what you need.
Right. There are other data structures like hash tables that are much better for that.
So it's all about using the right tool for the job.
Always.
Okay, now I want to get a little geeky here.
Yeah.
Let's talk compilers.
Compilers, those things that translate your code into something computers understand.
Exactly. And they use linked lists too.
They do, specifically for something called a symbol table.
Okay, symbol table. What's that?
Think of it like a dictionary for your code.
Interesting.
When you write code, you create variables, functions, all these named things.
Uh-huh.
The symbol table keeps track of all those names and what they mean.
So it's like a reference guide for the compiler.
Yeah, so when the compiler sees a name, it can look it up in the symbol table and know exactly what to do.
And how do linked lists fit into all this?
Well, code can get pretty complex, with variables being defined and used in all sorts of orders.
Not always in a nice, neat line.
Definitely not. So a linked list gives that flexibility. The compiler can easily add or remove symbols as it goes.
It can adapt to the chaos of coding.
You got it.
Man, these linked lists are truly versatile. All right, last concept I want to tackle, and it's a big one. Dynamic memory allocation.
Ah, yeah, how computers manage their memory.
Exactly. It's like a giant game of Tetris, right?
In a way, yeah. And linked lists play a key role in making sure everything fits nicely.
Okay, but how?
Imagine you have a bookshelf, but you don't know what size books you'll be putting on it.
Some big, some small, I see.
Right. You wouldn't want to divide the shelf into fixed size compartments.
Then some books wouldn't fit, and you'd waste space.
Exactly. So dynamic memory allocation lets the computer grab chunks of memory as needed.
Without having to predefine everything.
Right. And when a program is done with a chunk of memory, it can be released back into the pool.
So it's like a constantly shifting landscape of memory, always adapting.
A very poetic way to put it. And linked lists make that whole process much more efficient.
Wow, we have covered so much ground today, from playlists to browsers to compilers to memory management. It turns out linked lists are truly the unsung heroes of the digital world.
Absolutely. They're the backbone of so much of what we do on computers.
It's amazing to think that such a simple concept, just a chain of nodes, can have such a profound impact.
It really is. So next time you're listening to music, browsing the web, or just using your computer, take a moment to appreciate the humble linked list.
It's working hard behind the scenes, making sure everything runs smoothly.
Silently powering our digital lives.
Well said. That's it for this deep dive into linked lists. Thanks for joining us.
Until next time.
See ya.